graph the linear inequality 2x minus 6 is greater than minus 3y. Okay, now this is not standard form. What do I mean by standard form? We're talking about putting the x first and then having the y and then having your numbers on the right hand side. That's called standard form. Alright? Now true standard form, x must be a positive number. Okay, and it is up here. X is a plus 2, so I don't have to worry about that. The problem is I don't have my y term on the left side of the inequality. The y term's over here. So this y term is going to have to come over here, and this minus 6 is going to have to be on the right hand side. That's called standard form, and it's really pretty neat, really. Okay, let's put some space in here, someplace to write that 3y. Okay, draw a line, add 3y here and here. That will eliminate this negative 3y from the right hand side. It'll put it over here. Now this negative 6, it needs to come over here. So I'm going to add 6 right here to get rid of this one and add 6 here. Now this is going to be standard form where we have ax plus by equals or is greater than the c or 6. Alright? Standard form. And standard form is cool, okay, because we can find our intercepts real easy, okay? In other words, okay, when y is 0, what's 3 times 0? Huh? It's 0, isn't it? What's 2x plus 0? So this is gone now. When y is 0, this is gone. Okay? So 2 times 3 is 6, isn't it? Divide 6 by the 2, you get 3. Alright, so here's my equation. We got rid of this 3y right here by putting in 0. X ends up being 3. So here's one of my points. My other point is when x is 0, then what's y? Well, put 0 in for x. 2 times 0 is 0. 0 plus 3y is 3y. So when x is 0, we cover up this part right here. So we cover it up. 3 times 2 is 6. So in my equation, the y has to be 2. When x is 0, y is 2. Now the point 3, 0, that would be right here. We call it the x-intercept. It's the value of x when y is 0. Okay? The point 0, 2 is right here. Okay? Now we're going to draw a dashed line because it's greater than. It's not greater than or equal to, so it's just greater than a dashed line. Okay? By the way, if you put the 2 over the 3, you'll have your slope, won't you? The thing is rising 2 and running 3, isn't it? Huh? Go back and look at this. If you look at your original inequality, put the 2 over the 3, that's your slope, okay? Now, it's a negative slope because it's going upward to the left. The slope of the line is a negative 2/3. So you can actually, without doing any of these points or anything like this, I can look at the 2 over the 3 and tell how it's going to slope. With a plus like here, you're going to have a minus slope, okay? Well, that's another lesson, okay? Right now, slope is 2/3 upward to the left. A minus 2/3 is the slope. That's another lesson. But what we want to do now is graph this point, which is 6 to the right. Go on, count it with me. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Now, if I put 6 in here and 6 in here, do I get a true statement here? So that's the question, okay? Take your 6, 6. In place of the x, plug in a 6. In place of this y, plug in a 6. Okay? We're getting 12. We're getting 18. Okay, which is 30. And that is bigger than 6. Yes, the point 66 satisfies the equation. This point here satisfies the inequality. All right? Because 30 is bigger than 6, we say, hey, fill in that dot, fill in the 6, 6, and by the way, fill in everything on this side of the inequality because this point works, okay? The point 0, 0 doesn't work, does it? Well, what is 2 times 0? 0. What's 3 times 0? 0. 0 plus 0, 0. Is that bigger than 6? No, this point doesn't work. But every point on this side of the line, of the dashed line, works, okay, and none of these do. So I just graphed the linear inequality.